So this is a question 5 in which you're going to be writing to a file. You've got your specification with your bullet points at the top. It essentially, once you read it through, it wants us to create a record for different types of trees. Use commas to separate the different fields in those records, so things like the name, the number of trees, and the health score of the tree, and then write each record to a separate file in an output file. And what you'll see is that they want the file to be configured with no extra lines at the end. So let's have a go. So here we have question 5. They've given us a fair bit of code already, and we need to build it bit by bit. Again, we can see that we've got some arrows here telling us to write our code here. It gives us some ideas about opening the file, closing the file, using iteration to process each line, comma separated value lines creating. So it's effectively telling us in here in the comments what this actually wants to achieve, so what it actually wants to achieve from the specification. So let's see if we can build this bit by bit. So we need to construct a record for each type of tree consisting of fields for name, number, and health score. Well, somehow we are going to have to be able to work out where we are in any of these lists. So we're going to need to be able to use these lists and combine them together, because if you look at it, we've got maple, which is in position 0 in that first list tree names. We've got tree counts, which is in that first position 0 for this list, and then we've got the same sort of thing for tree score again in position 0. So we need to somehow keep track of these positions. So the easiest way to do that is, as you've always done with lists, is to try to use the index position. But in order to do that, we need to have a variable to store that. So let's pop that in first of all. So index equals 0. Give myself a little bit of white space there. If you want to, you can put a comment in, but I think it's a really good idea, and particularly this kind of question where you're going to get marks for commenting, white space and layout. So hold the index position of the tree record. Okay, so that gives us a way of figuring out where we are. Okay, so now we need to start to look at the rest of this, and it says open the output file for writing. So what it wants us to do is to open a file that we can then use to save data to. Now, one of the weird things about files, and you'll see this in the PLS, is that you don't start off by creating a global variable. You start off by actually opening the file with an object, a file object. Now, it doesn't matter what you call it. I'm going to keep it really simple here. So tree file equals, and again you can use the PLS here, open, that's the file name, out file. I can tell that because it's given me up the top here, and I want to open it to write, so I'm going to put a W in there. If you're not sure, again check the PLS. So that opens the file up to write. Again, I'm going to put a comment in here just to show that I know what's going on. So open out file for writing records. The next thing it says is use iteration to process each item in tree names. Now, there are two forms of loop in Python. The first one is called a while loop, and that's just a standard repetition. However, the second style is called an iteration, and what Edexcel means by that is that you iterate, you go through every item in the list. I'm actually going to put a comment in here just to remind myself of that, although it is in the PLS. Iteration means go through each item in a list. Okay. Now in order to do that, the command that gets used for iteration is the for command, or the for function. So let's just make a note there. So for. Now again, what we need to be able to do is to go for every single tree in the list, so every single tree in the tree names list. So we need to express that somehow. Now again, this is one of those funny ones where, a bit like the output file, you don't actually create a global variable to start with, you create it at this point. Now I like to make it really clear for each tree, so every tree in tree names. Okay, so for each tree in tree names. So what that's going to do is go maple, ash, sycamore, birch, hazel, willow, oak. It wants you to create a comma separated output line. So what I actually need is something to store the output line in some way. So I'm going to create another variable. Now because it's an output line, it's got a mixture of string stuff and number stuff. It must be a string. So output line is an empty string. So empty string variable to hold a record. I'm going to tidy up again a little bit more. So notice you can, as you go along, you can tidy things up, make things a little bit neater. So we have to build an output line, and we have to build it slowly. We have to build it in sections. So let's think about what we need here. The first thing we need to do is we need to have it output to the output line. We have to add on the tree name. So that's quite easy to do. So what we're going to do is we're going to go output line, and there are a couple of options here. You could do that, which I know a lot of you know how to do as a shortcut, or you could do this way, which I will do just to make it really clear. Output line, and you're going to add onto that, and this is concatenation, so it's adding it next to each one, and you'll see one of the issues with concatenation in a second. We need the tree name, and we need to separate it with commas. So if you look at this specification, it says use commas to separate fields. So plus, speech mark, and there's our comma. Okay. Now if you want to, and again this is, I think, really good idea, because it's going to get you marks, I would put a comment in here, use concatenation to build the output line. There you go. Okay, so that's our tree name and a comma. We've now got to do the next bit. Output line, again, it's a very similar thing. Output line plus, okay, what we need to know now, okay, is what the position is that we are talking about. So we need to get tree counts, but we need to know what position we're on. Now at the very beginning we start off on position 0, so we start off where index is 0, so that makes it a little bit easier. So we know we need to link maple to 137, both of those are in position 0. One other little issue here is because this is concatenation, we can't simply add this on without converting it, so we must convert it to a string. So that's a really important rule in concatenation. Give myself a bit of space. We want the tree counts list, and we want the index position, so at the moment that's position 0. And again we need a comma. Last one we need to do is very similar. We're going to go output line becomes output line plus string again, because it's a float but we need to convert it to a string. We're going to grab the tree score, we're going to grab the index position, which at the very beginning is just 0, and that's the end of the line, so we don't need to put a comma on here. We don't need to add anything extra here, so I'm going to make a little note of that. So no comma needed. Now, hasn't quite finished yet. Okay, we need to move to the next position, and this isn't given to you as a comment, so we need to be able to work that out ourselves. So move to next index position. So index becomes index plus 1. So now it's going to go from 0 to 1. That will match up because the next tree in the line in the for loop is ash. Ash is in position 1. 8421 is in position 1. 0.18 is in position 1. So that's all matching up quite well. Before we do anything else about writing it, we need to think about how this file is being constructed. And if I look at it, it tells me in the specification that there are exactly 7 lines in the output file. So there is no extra line after oak. So somehow what we've got to be able to do is to each time add a new line, except for the very last position. So we need to try and figure out where we are with that. So I'm going to put that into a comment so we can see where we are with it. Okay, so if not on the last line, add a line feed to the end of the line. So how do we do that? Well, it's an if statement, we know that. We need to know where we are. Now, one of the good things about this is that because the index is increasing each time, we know where we are. And we also know that we can calculate how big the length of the tree name array is. So let me put the code in and then I'll explain a little bit about how I've got there. So index is less than the length of tree names. So what that does is it says to itself, okay, if my index position is less than the length of tree names, what's the length of tree names? Well, the length of tree names is 7. So there are 7 trees, and there are 7 up here. So 1, 2, 3, 4, 5, 6, and 7. Each time my index position is going 0, 1, 2, 3, 4, 5, 6. How do I know that I'm not on the last line? Well, the last line, okay, has got to be where it is in position 6, because it's going 0, 1, 2, 3, 4, 5, 6. Okay. So the moment that it gets beyond that, so the moment that changes to a 7, so we're on oak, index is 6, then changes it to a 7. But the moment that changes to a 7, that is no longer less than the length of tree names, it's actually the same as the length of tree names. So that's how it stops itself from doing it. Okay, let's put on a line feed. I could have used a constant here, so I could have stored that as a constant up here and then used the constant down here. That's another way of doing it. It's totally up to you. Okay, so we've managed to build ourselves an output line. We've managed to move through each of the items, and now what we've also managed to do is add a line feed to the end of the line. We're now going to write the line to the file. Now, this is something I could have done a lot earlier, and one of the things that you can do is if you can't get this bit quite going, you can actually put that bit in, because it's going to be the same code regardless of whatever happens inside the processing bit, inside the building of the line. Writing stuff to a line, to a file, is quite straightforward. You're going to start with the file object, so in this case it's tree file. Again, the PLS tells us that it's .write. We're going to now output our string, so output line, and that's closed everything off. So that's written the line to the file, and the very last thing we need to do is to close the output file. And this is something that I would perhaps, if I was doing it for myself, I would do open the output and then close it instantly afterwards, so that I'm not going to get any problems with it staying open when I don't want it to. And that's quite easy to do as well. Again, we're going to take the tree file and we're going to use the subprogram closed and close it off. And that's my code